So we are doing 3.3 now. Now we may get to the end, we may not. It's quite a long one.
Just not shut up, have you?
So the SAC is gonna definitely have quadratics in there. It's definitely gonna have linear equations in there. Definitely factorizing and expanding. Everything you've done this year. So graphing quadratics. We know it's quadratic simply to power of 2. In your head, the best thing to do is just draw the general shape that might occur. Quadratics, parabolas. Just by looking at this, what information can we get for our graph when we sketch it? Y-intercept.
-5.
Okay, is -5?
Yep.
Okay. So it's 0, -5. And what's the next thing?
Gradient.
We're not doing gradient. Why?
It's parabola.
It's parabola. Gradients are only related to
Linear.
linear lines. Okay. What's the next feature of a quadratic?
What's it called when how much it varies?
We won't do that today. Dilations.
Yeah.
Okay.
Point.
That's a bit further down the track.
Turning point, yeah.
There's turning point. TP.
And x-intercepts.
And x-intercepts.
Remember.
Toilet paper. So y's, x, and turning point should always be your approach to any graph that you do. Quadratics and above. All the time. But how we get there can take a few turns. So we must always know what we're aiming for. Y-intercepts, x-intercepts, and the turning point. We've already found 0, -5. If I want to find an x-intercept, where do x-intercepts occur, Enrico?
Y = 0.
Sorry, what was the question?
Where do x-intercepts occur on a graph? When y = 0. Okay.
Explain that.
So, you've seen this before. There is a square there. There is a minus there. What are we going to lean towards?
Plus.
Oh, we can plus?
Yeah.
We'll go Shaka's way.
Yep.
What do we do?
Square root.
We do square root of 5.
Mashallah.
Amy, when you do a square root of 5, what must we do?
Plus
or minus.
Mashallah.
So we've got a square root of 5. Now think about square root of 5. It's roughly, if you put that in your calculator, it's roughly 2.2. So I put my 2 intercepts in there. We've done that. I'll look for my y-intercept. It's a -5. Let's go in 2s here because I'm going to run out of space.
So is that minimal something like minimize?
Minimal.
What is it like a maximum or minimum?
Yeah, we'll get there. I'll get there. And if I have, we've done 2 things. I wanted a turning point, but if my x-intercept is one way equally right of 0,
it's -5, the turning point,
and -√2, where's the turning point
-5
going to
on
sit?
the y-intercept.
Yes,
Bang.
right here. They're going to be, our turning point is at 0, -5. Now, remember, this is a sketch. Your sketch just needs to be clear and neat. It's not a work of art. And that confirms that we've got our quadratic.
Is the turning point always going to be 0 on the x-axis?
No.
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 Okay.
Okay. The other way,
I could do that. That's pretty easy.
here's another way of doing it. Alternatively,
No, it's just normal 5, isn't it?
okay, is this the same as that?
Oh, we can do dots.
Dots. Good checker. Dots. I can convert that into a square root of 5.
That's so much harder. I'm not listening because I confuse myself. I'm not listening. I confuse myself.
If it's a dots, what's in the first bracket, Maya? If this is a dots. Good. And? Good. And then you can make them both equal to 0. And you'll still get the same answer. You might want to do that. Okay, you can do it that way if you want. Maybe your brain leans that way. Okay, first one done.
That's what was fun. He only bought that for people who ask questions.
Last
You know, doing this help. Makes sense.
Okay, next one. Next quadratic. Which way is this pointing, Zach? Zach? Down. It's going down. So why is it down, Zach? Because it's a negative. Okay. What if it was this?
Then it'd be positive to the other way. Because it's two negatives make it positive.
Is it down or up?
Down. No, the opposite way down.
Up.
2 negatives make a,
Positive.
and a positive and negative make a.
Negative.
It's still down.
What?
It's square.
Yeah, because there's a square.
Like that.
Okay, sorry.
Okay, whatever's the negative side, always gonna be negative. It's always gonna be down.
Okay, same approach. 3 things that we need to figure out. Y-intercepts, x-intercepts, and a turning point. 3 things every single time. So, let's do x-intercepts. When x are the intercepts, what do we put in our equation? Y equals 0, thank you. We can do that. Okay. Now we're going to solve for it. What happens to the negative? It's a negative 1. What's 0 divided by a negative 1?
0.
It's 0. It just goes.
Oh. So we can just kick it off.
Yeah, just kick it.
Alright.
Okay.
That's fine.
Square. Opposite of a square. Square root.
Oh, yeah, I remember this. We use
Square root of 0 is?
0. So you can just keep leaving.
I remember that. Mr. O'Brien told us that.
Good.
X equals
Oh, you went
negative
even
3.
X equals negative 3.
You
Now,
can actually just look at that and go, oh, that's just negative 3.
yeah, that's right. You can do it that way too. Okay. Do I need to put a plus and a minus on this?
Nah,
Because 0 is neither plus or minus. Okay. Okay. So we look for negative 3. It's right here.
how do you find the other one, man?
Okay, there's only one here. All right. You'll see what's happening here. Y-intercept. What's the y-intercept in here?
X equals 0.
X makes 0.
It'd just be 0, wouldn't it?
Are you sure about that?
No.
What's our final answer, Nathan?
9.
9?
Negative 9.
9 or negative 9? Okay, the negative is not inside, so it doesn't disappear. Go for a negative 9. Negative 10 is down here. So negative 9 is down. Now, notice carefully. Hey,
Right, lock in.
we established this is going to be a parabola going downwards.
Yeah.
But we've only got that point and that point to make our quadratic.
That's a turning point up there.
This
The
one here?
x-intercept. Yeah.
Correct.
Ooh.
Okay.
I see that. Thanks, Tim.
It must go in.
Can you get rid of that? Oh. No.
Okay.
But that's freaky.
Okay.
So that was pretty good.
Okay. What is the clue when you see most of the time when you see it touching here?
Yeah.
What's the giveaway in the equation?
What do you mean?
Well, I'm not going to go down there because it doesn't always. Forget what it's. Okay, moving on.
You don't need to pass it up. All there is to go on to the path for us. That's validated.
They're getting harder.
Oh, that's good. Okay, awesome. So oh, it's just a random. No, it's just I see that's how you say how I'm saying. Really? Oh, I see. Okay, I don't know where it's high.
I've seen it once this year.
I don't know if it's not the same way. Oh, that's the next half marathon.
Still looks sleepy.
Oh, that's a great speak. No, it's speak.
Right.
This one.
Any graph, I said there's three things we got to keep doing: y-intercept, x-intercept, turning point.
Yeah.
Let's tackle the x-intercepts. All right, y equals 0.
-2. Alright, so we can do add 3.
Okay, we're gonna solve this together.
Add 3.
Gonna add 3.
And then do you times it by -2 or do you plus
divide.
-2? Yeah, do you sorry,
Divide by -2. Just by looking at this already, does everyone know what the conclusion is?
It's going to be
X.
rejected because it's a negative.
Yes, it is.
How the balls?
Okay, undefined, rejected, undefined. So that's not happened. There are no x-intercepts in this one.
So it's just a straight line.
No. Let's do our y-intercept first.
Oh,
Point intercept at the y, so it has to be below.
has to be a negative and it's going to be down as well.
Yes.
Yes. Mashallah.
No.
No, that's not so wrong.
Okay. Hudson McMillan, can you help me with this? 0 plus 1 squared.
1.
1 squared.
1.
What does that turn into?
2.
Wait, sorry, no.
1.
What's the intention?
-2 times 1, Hudson?
So, -2.
And -3.
4. It's not 5.
Okay, 3. So down here, -5. Okay. So we have an undefined. We still need a turning point. Does anyone know by looking at this? Where's the turning point? Okay.
Why?
Tim, do you know where the turning point is? Just by looking at the equation.
-3.
It's at -3. And?
-5. -2.
Probably yes. If you want to find the turning point very quickly,
How do you know that?
we'll prove it. You do the opposite of the bracket. If it's a +1, it lands on -1. But the -3 outside remains as a -3.
There's so
many
many
different
little tricks and things.
Now, but I'm going to prove it to you. Do you want me to prove
So we
it?
believe you, we believe.
This is
Oh, there's still 40 minutes until lunch.
That's true. I need.
So -1, -3 is here. Goes through 0, -5. We know it's a negative parabola. And it's a bit off the page. If you want to know the full working out with that, I've got it in the notes. All right? It's just a substitution. Okay. Who's good at completing the square? Who loves that?
Not us.
That's great. Okay.
I don't know what to do outside.
So, shh. Sometimes, look carefully. Just by looking at the question, you can get information straight away. Okay. Who's Zaid? You got some information from out one of these? What can you see from there? Which one do you think you know straight away?
Any point.
No.
One second.
X-intercept. Okay. It's the y-intercept. When everything, if there's no brackets involved, and it's written straight out, you have a y-intercept.
-10.
-10.
Oh, what? Yeah.
It's there already.
Does that have to do with the MX plus C?
No. What it does mean is that when you sub a 0 into here, guess what's left?
-10.
-10.
When you make x equals 0.
When you make x equals 0,
Ah, I see.
okay, so sometimes you can get stuff straight away. Now, if we're doing x-intercept though,
We make y equals 0 plus 10.
what's
Plus 10.
what are we going to do here? There's a few ways we can do it.
We could take x out.
Can't take x out.
We could plus 10. Fraction. True fraction.
Two fractions? The two brackets?
Yeah, that's what I'm saying. Take x out.
Oh, is that what you meant?
Yeah, and
Like
then
that?
take x. You take 2 out. 2x out.
Oh, take the 2 out. Let's take the 2 out.
Yeah, that's what I meant. Hey,
Oh,
right.
is that what you meant, Shaker?
Yeah,
My
I
bad.
right. Yeah, but I said it first. Yeah, what?
Okay, good. You're both right. Okay, hold on. We take the -2 out, but let's look carefully. Can I break this up, this bit here? Is it possible? It might be possible, actually. I don't know. Can I do this?
No, you can't.
-5 plus 1.
Plus 5.
But does a -5 and a +1 make a +5?
No. Oh, wait.
Yeah, that's okay. I'm just trying to get your thinking to come out. I'm not saying that. Okay, so that doesn't work. Okay, what I'm trying to say is, if you try to do a break of two brackets, it doesn't work sometimes, and you can't. You get stuck.
Can you do positive 5 and positive 1?
+5, +1.
No. They're plus equals 6.
Because there's a minus
Okay.
and then.
When you get stuck, you complete the square. Try to complete the square. Okay, let's complete the square. Who was good at completing the square last year?
Emily was quite good at this.
Thanks, Hudson.
Okay, we're going to complete the square. Do we know the rules? We write the first two things down in the bracket.
And then
So,
you times isn't a second and then divided by 2.
yeah. So the second thing gets divided by 2.
You go minus 4 over 2.
Minus 4 over 2.
Plus 4 over 2.
Good.
4 over 2 squared.
Okay.
It's a very kind person.
Now, have these two, I've mixed that up. That's a plus and this is a minus, my bad.
They cancel each other out, don't
They cancel each other out, but we need them right now. We're not going to cancel them out. These two are the same still.
they? Well, our first one would be negative
Okay.
4 and second positive.
I'm just going to repeat the second term gets divided by 2.
But listen.
One gets plus and one gets minus. And they both squared.
Yeah, understand. So -4 and 4.
Okay, so when we keep going, what does this change into?
4, -4.
No,
What? 2, -2 squared.
-2 squared.
Oh, +4.
Just a slight cleanup. These are still the same. 4 divided by 2 is a 2 still. And then, does anyone know what we do from there? I'm going to highlight it in red. This bit here.
Well, then we do the plus and minus thing
Okay.
with that.
Okay. So what gets written first?
We get take 2x.
Okay. It's
-2.
x minus 2 squared.
Oh yeah.
Okay.
Can we do perfect square? No dots. Probably not though.
No. Okay.
So that's one.
Over here, don't forget, what's -2 squared?
+4, -4,
5.
5.
Okay. Now be careful. Be
One.
careful. This bit here, these three terms shrink to this red thing in here. Do you believe me?
I believe you, but I don't know.
Does anyone not believe me?
Oh, I believe that.
Okay.
That's why we have.
Okay. When you expand this out, this middle term pops back in there. If you go backwards. Okay. All right. X minus 2 squared. What's Perry? What's at the end? 1. All right. Keep going. There's another advantage to completing the square, and I want you, if you say it, you get a lolly, another lolly today when we keep working this out. Okay. We've got to keep going here.
Now,
I'm just going to create square brackets here. Just what's our final answer?
I don't know.
Okay. I'm going to multiply that 2 into each of the brackets here because that gets applied to everything. What's the next term?
-2.
Good. A lot of people will forget that. Looking at this, oh, that should be a y. My bad. These should have all been y's because we weren't doing a factor law. I was just in that mode. My bad.
She's not good enough.
Over here, what's the conclusion? What now do you know? Good, Emily.
Would it
The
be
turning
2?
point.
Would it be 2 -2?
Not quite.
-2, 2?
Not quite. 2 -2.
I said that the first time.
Did you?
Yeah.
No, he didn't.
You did it.
Why?
Shut up then.
2 -2. What is the advantage of completing the square? The turning point pops up when you change it. What's the advantage when everything's multiplied out? As at the start, the y-intercept. These two are the same things, but they're telling two different stories. Turning point, y-intercept. Okay? Say it.
Why is like everything to do with math now always graphic?
It's a really, really good point.
Mathematicians like pictures.
Yeah, like why do we all only ever do graphic? Why does it just have to end with a number? Why does it end on a graph?
Are there any jobs that actually use that like that?
I don't know.
Is there any jobs that use parabolas and that?
Hmm?
I was trying to figure out, like, someone that does like banking or something like that would use a parabola.
No, you won't.
Yeah, like why?
Why would bankers use parabolas?
Like
Because
the gradient.
Shaka, the system,
That's what's
the system. Oh, it's a long story. You really want to know?
like, is there any other job other than math teachers that you need to know this stuff?
It's all to aim.
Be recorded. I don't want to say. Okay.
Probably.
Last bit for this, and then we'll graph it. I'm gonna. Good news, Shaka. I feel after this question, we're not going to keep pushing forward. I'm going to try and bring stuff over to the next period. So you'll still have the notes. X-intercepts is the last thing we have to figure out. Let's go. Backtrack. Who haven't I picked on yet?
Zaid.
Zaid.
So you've already picked on me.
You should get up and
I haven't
back.
picked on Shaka though.
Bullshit.
Shaka.
Yep.
What's the first thing I move?
-2.
Becomes.
Yep.
What's the next thing, Jesse?
Divide by
Next thing, do I get rid of?
Divide it.
This two or this two? The first or the second one? Very good. What are we going to conclude?
Undefined.
Undefined. Very good.
Good shit, Perry.
Hey. Language.
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 Being recorded.
Okay. I'm going to graph this. Almost there, guys.
Give yourself space.
It's right next to me.
Okay. So it's in the middle.
It's like a grown up.
It is like so when you float so hurts you. If you learn checkers,
How old your brother is? He walked through the locker bay when we were about to go to the bathroom.
So when we're graphing, just listen up. Our turning point is at 2, -2, right there. Is it going up or down?
It's going down.
And we know we're forced to go down because the y-intercept is down there. You're not going to do one of these because it's not. There's nothing there. It's right here.
Yeah.
Okay. So that's that. Now, alternatively, to figure out the turning point from here, this is nice. Turning point is here. There is another way though to get it from here. Does anyone know what we do?
To go from there. No.
Is that what you say? Okay. Yep. So if you want to get the let's do it this way. This tool, and everything is expanded out, and we allocate the x squared has the a's, the x has the b, and the c is the y-intercept. If we use this formula helps us to locate the turning point when it's written out in expanded form. Over here, we just read it off. But technically, this is an x, so we should be getting a 2 when it comes out. What's our b?
8.
And what's our a?
2. -2.
-2. What's our answer?
2.
2. Okay. Once we get our 2, we can then put it into our formula. And what should we get as an answer? We should get a -2. Okay, that is -2, isn't it? It is -2. Done. It's up to you. There was actually a lot of working out to get to this, wasn't it? We completed the square. A lot of working out. There's another way. You can allocate A, B, and C. Use this here to get your turning point another way.
Right.
And that's up to you. And that's in the notes as well. Okay.
I like that other way. I thought it was too.
You like completing the square way?
No.
Are you just like this? Yeah.
Like that.
Question, Emily? No? Okay.
Anything more weak.
All right. We're going to stop there. I know your brains are fried.
Thank you, sir.
We will continue next period.
Mashallah.